Hello everyone and welcome to my third Rust Quickie. In my last Quickie I have talked about the cargo package manager that comes with Rust, and today I want to talk about the various integer-based data types that Rust provides you. So let's switch now over to Visual Studio Code, where we will look in more detail into those data types. Like every other programming language, Rust provides you so-called signed integer data types, which are based on the deuce complements representation, and in addition Rust also provides you, of course, unsigned integer data types. Let's talk first about the signed integer data types. As you can see here, we have here a data type called I8, and that is just a signed integer with 8 bits. We have also an I16, I32, I64 and I128 data type. So the only difference in those data types is how many bits they are using internally to store your integer value. With those data types, you can also call some function with the colon syntax. For example, minimum value returns you the minimum value of that data type, max value returns you the maximum value. As you can see, those data types, they have a huge amount of different functions. So not only min and max value, but as you can see, you have here a huge amount of different other functions that you can call on those data types. So first of all, let's run that Rust code for our signed data types. So we do here a cargo run command, and you can see here the ranges. As you know, an I8 data type has a range of minus 128 to positive 127. You have the typical range of a 16-bit integer, 32, 64, and also for the 128-bit integer data type. One very specific data type in Rust is the so-called I-size data type. When you are working with other programming languages, they don't support that data type. The idea of the I-size data type is that it has the size of a so-called machine word. So the size of that data type depends on your CPU architecture. When you're working with a 64-bit CPU, like in my case, that data type has a size of 64 bits. When you're working on a 32-bit CPU, that data type has a size of 32 bits. So it depends on the size of your machine word, and the machine word depends on your CPU architecture. And as you can see from that output, the range is the same as the range of the I64 data type, because I'm running here the 64-bit version of Windows 11. So very simple to find out the ranges of those signed integer data types. In addition, you have the same with unsigned integer data types. Again, we have a U8 data type, which is 8 bits long. We have a U16 data type, U32, U64, and U128. And again, we also have the U-size data type, which again represents the size of your machine word. So in my case, it is 64 bits long. So let's run that additional code. We do again a cargo run command. And as you can see, the U8 data type unsigned integer goes from 0 to 255, U16 goes from 0 to 65,535. Then you have the range for the 32-bit integer, 64-bit and 128 bits. And again, you see the size or the range of the usize data type is the same range as for the U64 data type when you're running on a 64-bit CPU. Again, when you're running that code on a 32-bit CPU, you would have that size of the U32 data type. Okay, let's work now with those data types. Let's define some variables. In Rust, this is called a so-called variable binding. Means you have some value, like the value 12, and you bind that value to a variable. Like in my case, we are binding that value of 12 to a variable with the name a. As you can see, you use here the so-called let statement. You specify the name of the variable followed by a colon, and you can specify the data type. You can specify the data type because Rust is also able to infer automatically the data type. As you can see here, I have here a let b statement. I have defined a variable b, and that variable b is assigned in the next step the value of 42. Means we are binding that value to the variable b. But as you can see, I haven't specified here any data type. So the Rust compiler infers the data type based on that provided value. And as you can see, the variable b is an I32 data type. In addition, you are also able to specify the data type with a so-called suffix. As you can see here, the variable c has a value of -42, and I'm assigning the data type I16 to that variable c. It's the same here with the variable t. We have a value of 85, and we are assigning the data type I16 to that variable. So you have more or less different ways to define such a variable binding. You can explicitly specify the variable, the data type. The Rust compiler can infer the data type automatically for you, and in addition you can also use a suffix with the data types that you see here on the top that we have mentioned previously. And afterwards, let's calculate something. As you can see here, the variable e is just the multiplication of the variables a and b, and the variable f is just the multiplication of the variables c and d. And afterwards, we use again the print line marker to print out those variables. The question is now, how do you print out a variable? In my last quickies, we just have printed out string constants. But now we are printing out a variable, and Rust provides you here in those parentheses a so-called placeholder. So that placeholder is replaced by a variable. So the first parentheses are replaced by the variable a, the second ones are replaced by the variable b, and the third ones are replaced by the variable e. Those are so-called placeholder values in the print line macro. So let's run now everything again, and as you can see, we have here the result of the multiplication of 12 multiplied by 42 and the result of -42 multiplied by 85, minus 3570. So that's the idea of integer data types in Rust. In my next Rust Quickie, I want to talk about other data types that Rust supports. For example, Rust supports floating point numbers with single and double precision. We will talk about the bool data type, and we will also talk about the char data type. So thanks for watching. Maybe you can leave me again a comment how you like that YouTube series. You can also subscribe to my YouTube channel, and I'm looking forward to see or hear you next week again. So thanks for watching and stay tuned. Thank you.